Whose day is it today? It's Wednesday. As you know, the days of week are named after Norse gods. So today is Odin's day, Wednesday. Tomorrow's Thursday, and then the day after Friday is Freya or Freaks, based on who you ask. So whose day is it on Tuesday? Anyone? Any expert in Norse mythology? No. Okay. Tyr, nice. Yes. So the guy is called Tyr, and the word has the same root as Zeus. Zeus, which means God, basically. Deva, which is also God in the Indians in the house, and Dev, which is the Persian word for demon. So all of them are gods except for one. And why that happened? Because this guy Zarathustra came around 2,500 years ago and said, yeah, so half of the gods are bad people and then half of them are good, and then there is a fight and you have to choose a side. Before that, they were just gods. And so the Dev became the bad guy, and there was this other god, Ahura Mazda, who became the good god. So, and this happened also in India, but the other way around. So Deva is the good god, and Asura are the bad people. So Indians approve, yeah. So we're going to talk about gods turning into demons or CVEs. Yes, so that's me. Very not accurate presentation of all my muscles. So I'm a backend engineer, Dr. Captain. If you're not from Germany, you'd probably never heard of my company, bike leasing company. So we give other companies bikes to give to Doria. And so I have written also this nice book here, which I usually give away in conferences, but there was a supply chain problem. So today I give you a code to get 50% discount. So the code was #morgeka. So if you use that code, you can get 50% discount. Yes, on this website. So let's fight CVEs together, because usually, so who knows what CVE is? Okay, nice, good. So a few people don't know. So CVE is when there is a security issue with some package or something, there is a database record created somewhere, and then they say, okay, this package with this version number has this issue, and then you should probably change the package you have installed in another version. And then which CVEs do you know by name? Yes, or an older one. So there is React to Shell that happened last year, I think, during December. Does anyone know React to Shell? So if you had a React front end, people could basically run any script they wanted on your servers. And Log4Shell happened 4 years ago already, 5 years now. And yeah, so it was a 0-day vulnerability discovered in 2021. And then everyone was talking about SBOMs after that. Who knows what SBOM is? Okay, good. Yeah, because why is it important? You have, so when you buy something like, let's say Nutella, and then there is a part on the back that says ingredients and says like 90% sugar and some chocolate and stuff. And yeah, this is basically what happens with your software. If you have a list of all the ingredients of your software, if something like that happens, then you can take a look in your list of ingredients and say, okay, I don't have this vulnerable version of this package, so I'm good. So this is why SBOMs became more popular back in 2022. This is me younger and more fit, I think. And then we had 2 workshops in the same month, two meetups talking about SBOMs and why are they important. And Docker introduced the SBOM CLI plugin back in 2022, which is this one. If you have a Docker image, you can use this command to get the SBOM out of it. This is basically using Syft under the hood. And they also created, they want to get rid of it, I think, but this is still there. So they introduced this other one, which is Docker Scout SBOM. So yeah, if the other one didn't work, you can use this one. And then you can, if you want to extract the SBOM and save it in a file to use later, you can use this other command, which gives the format and output and stuff like that. SPDX is a good format if you don't know which one to use. And it's important to be able to generate SBOMs because very soon you have to do it. There is this EU Resilience Act. So if you create anything that has software on it, you have to generate SBOM for it. So if your toaster talks to Alexa, it should have SBOM. So that was the SBOM part. Yeah, the gods are having fun too. And yeah, so no one cares about us. So basically, the CVEs, someone says we have CV issues. There are so many supply chain attacks recently, and then yeah, so leadership doesn't care. We have to fight the CVs ourselves as engineers. So yeah, this is how it looks like currently. CVs attacking left and right, and yeah, so the gods are summoning some people to fight this called the Docker commandos, and they arrive to save the day. Yes. Yeah, and yes, also exactly the representation of my muscles again. Yes. Yeah, so let's use some Docker commands to fight the CVEs in the beginning. So the first one is Docker Scout. So the commando is sent out there to get the CVEs. This is the command, Docker Scout CVEs, and then you give it the image name, and it gets all the CVEs in the image. So who knows any other tool to do? Yeah, Trivy does the same. But yeah, so you should be careful with that one. And one thing about SBOM is that if you have a multi-stage build, if you use something like Docker Scout CVEs, any standard scanner of Docker images can look at what you have in your Docker image at this stage, that last stage of the build, basically. If you have some dependencies that are in earlier stages, they might still copy some code into your image, and they're not shown in the last stage of the Docker image. So you want to do something that is called SBOM attestations, and this is basically having the SBOM generated and then put it into your, bundle it with your Docker image. Basically, you have some checkpoints and then check people and then give them some records and stuff. This is how it works when you're building a Docker image. You say SBOM is true. If you use this command, the SBOM attestation that is built is copied inside your Docker image. And this command out of the box only includes the last stage of the Docker image. If you want to include the earlier stages, so this is one nice example. So if you have a seed image, for example, the first stage is where all the dependencies are, and you might end up with just one binary, and your last stage is just from scratch, and it has 0 packages in it. So if you scan this image with a normal dependency or the vulnerability tracker, they would say nothing is in this image. But all the dependencies are in the first stage, and you want to add this argument there, build kit SBOM scan stage is true. And if you do that, when you do this SBOM attestation thing, it will include the SBOM from the earlier stages as well. And Okay, so time for Sophie, because almost halfway through. Okay, thank you. So, and these are the Norse runes. All of the things that are written on the slides are real words. You can read them with this thing later, if you want. And so there is also Docker hardened images. Who have heard of Docker hardened images? Okay, nice. So Docker created this set of base images called Docker hardened images, and these are open sourced last December, I think 13th of December. So they're basically very fancy, very muscly people, and they won't let any CVs enter your Docker image. They are Nero 0 CVE images, so they almost have no CVEs. They have a few. So if they have a few ones, that's because they're not fixed. And this is how it works. If you have Node 24, for example, as your base image, you just prefix it with dish.io, and you have your hardened image. And they're free to use. There are different variants of hardened images. There are dev images, which have root and package managers and stuff like that. So if you can use them in your earlier stages of your Docker build, because you want to install this stuff. And the production ones are, they don't have root, they don't have shell package managers, anything, and then you can use them in the last stage. And these images come on Alpine and on Debian. So basically, if you don't have to do anything. So you just change the base image based on what you're using, and then you don't have to edit the rest of your Docker file. And for the node, last time I checked, if you use the normal image, it has like 169 CVEs. The hardened one only has 8 low severity CVEs. So a lot better. Yeah, so you want to learn better, you can read these very nice blog posts. And also one other thing, I think there's also a workshop about this tomorrow. You can learn more hands-on. So many CVEs are noise. You want to exclude them from your things, from your pipeline and everything. And so basically the CVE, one of them is harmless, as it's just depressed, having a beer. And you want to give them a VEX attestation that says, okay, I know this image has this CVE, but we don't care because reasons. So you give them a card that says, yeah, this guy is useless, don't track them down. And this is how it works. There is this thing called VEX-CTL. You can create a VEX record that looks like that. So the author, the product, that's the image that I'm creating this VEX thingy for. That's the vulnerable package. That's the CVE that I want to exclude. And that's the justification. Okay, vulnerable code not in the execute path. So it's vulnerable if you use it this way, but I'm not using it that way, so I don't care. And then you can add this attestation to the Docker image with Docker Scout. So this is how it looks like. It creates a VEX attestation, and then next time you scan your image, it will also include that exemption in your results. And apart from that, you want to sign your images and your attestations. Yeah, signing all the docs. And who knows OCR refers? Okay, so for now we talked about SBOM attestations and VEX attestations and all these different sorts of attestations. If you use Cosign to add an SBOM attestation, it used to use another way that were Cosign attestations. The build attestation lives inside the image. The VEX attestation use another way of doing stuff. So it was a mess, and then the community came together and said, okay, we want to, and this is called these things, and this is called OCI refers. It's basically means that your attestation lives in the container registry as its own thing, and then you can refer it back to the image that you want to assign it to. If you use Cosign now, it creates OCI refers out of the box, if I'm not wrong. So the thing is that if you want to create an SBOM and then sign it and then assign it as a with Cosign, for example, in case of the one that we created with SBOM from all the stages, you want to write your image into disk so that you can extract the SBOM. For every stage that you had this argument, you have an SBOM, and you want to attest, so basically attach all these SBOMs to your images with Cosign. So it signs them all and assigns them to the image that you have. There is this other tool called Auras that is for managing OCI referrers. If you look into the Docker hardened images, they have like 20 different attestations. You can check them out and see how things work. And we get to more interesting parts. We have to get through it. So 0 day is one of the Docker commandos was himself at SPY and at CV. So who knows about the 3V vulnerability that happened last month? So 3V is the image scanning tool, and then it had a vulnerability that would steal the secrets on your CI pipeline. So your weapon turned against you. So far, so this is the whole pipeline. We talked about distribution mostly. If you want to distribute the SBOMs and stuff like that, we talked about dependencies. You want to choose dependencies that are not vulnerable, less vulnerable. And the build part is something that we also need to care about because there are more and more attacks on that stage. So let's dance. Who knows about Salsa? Okay, so there is this thing called Salsa, written without an A here. So these are some standards that if you follow, so to make things better, there are different ways of like different levels of having hardening for your build stage and the build track stuff. So the first one says that you have to create a provenance for your Docker build. I think any artifact, but in case of Docker, you can do a provenance attestation. The second stage says that your build platform should be hosted, so no engineer building and pushing to production, to registry basically. And then the last one says hardened build, so different builds should not have an effect on each other, because if an attacker gets into your build mechanism, they can leave something there and then abuse that. So some other stuff. And the sign key is not accessible in the build steps. So the parts that are defined by the developer should not have access to the keys, so that you can't extract them. To create provenances, this is how it works. When you're building your Docker image, you can say, also give me an attestation of type provenance. The mode is min or max, and then there are different versions. And on min, you have things like the build timestamp, what was used, the source repository, and the build platform, which machine was used to build it. And on max, you have more stuff like the Docker file is also encoded into the image, and then you can, if there was an attack, you can see, okay, how was this image built? And you can look into these things. So who can read this? This is a poem from a Persian poet. So it says, if sorrows gather to overwhelm all hearts of lovers, the cupbearer and I will unite to dismantle its foundation. So cupbearer is the one who brings wine. Fans divorce to say drink more alcohol. But the poet himself had the nickname Lisan al-Gaib. That rings any bell? So there was a few attacks last year, and also the last one was on 29th of April, a few days back, last week. They were called Shai Hulud attacks. There was Shai Hulud 1, Shai Hulud 2, and mini Shai Hulud that happened last week. So it's like Assassin's Creed 1, 2, and Brotherhood, basically. So the attack it's a worm that replicates itself. You install some NPM packages, and there is a post-install script that would replicate the worm, and then if you have other packages, it will steal your credentials and then publish it into other NPM packages, so that it's a bit dangerous and infiltrates the developer machines. And to a checklist, so no part of your supply chain is safe anymore. To prevent things like that, being vulnerable to things like that, you should harden your build mechanism, your build pipeline. Use it's also level 3. Pin your versions, so you have to exactly mention the version of the things you want to use. If you use latest or just the vague 3 or up, then if a new vulnerable package is published, you get it automatically. Have a cooldown on the installation. So if a package is published, wait for 2 days, for example, and then use it, because usually they are discovered if they're vulnerable within the first 2 days. Don't trust AI. The mini Shai Hulud also infiltrates your AI coding agents. They copy some scripts in your cloud thingy, I don't know, post boot thingy, so that when they boot, then they will infiltrate your machine, and use short-lived keys in your CI/CD pipeline, so that if one of the keys are exposed, you're not vulnerable, and then disable scripts. For the AI part, there is this thing called Docker sandboxes. Basically, you run your cloud or Gemini inside the micro VM, so that will save you from mini Shai Hulud, and disabling the post-install or pre-installed scripts by default, so that these things can't happen. And the most important one, have an incident playbook, because if something like that happens, you have to know, and you have to act fast, because you have to rebuild your things, you have to invalidate your caches and stuff like that. So outro, that's my LinkedIn profile thingy. If you want to find me there and curse and say, yeah, not very funny, you can use that. We talked about different parts of the supply chain. We also talked about build and source parts. And yeah, the first part about the VIX attestations and all this kind of stuff, there is a workshop, like you can do it yourself kind of workshop. You can access it there, and it works as a Docker lab space. You can launch it and it runs in your browser if you want to get a hands-on experience with them. Yeah, so that's it. Thanks a lot.